Okay, here's another example of using addition with probabilities. Basically, we want to find the probability of maybe more than one event, and those events might be overlapping. So what we want to do is we want to figure out which of these situations we have mutually exclusive outcomes and which of these we have overlapping outcomes. So the first one, let's talk about playing cards, sorry, just so we're all clear. A regular deck of playing cards that you play poker or whatever with, there's 52 cards in the deck. When you take out the jokers, which you don't usually play with, and the instructions and things like that. There's 52 cards total. 26 of them are black, and 26 of them are red. And there are 13 of each. There's 4 what we call suits, or symbols. We got 13 diamonds, 13 hearts, 13, these are called clubs, and then these are spades. So there's 13 of each of these, and there's 2 red suits, so 13 and 13 gives you your 26 reds, and then there's 13 and 13 of these. So 13, 13, 26 reds, and then you have 13 of these and 13 of these, which is 26 black cards. And for each suit, you have 13 cards, and the cards are ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then you have jack, king, queen. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So for each suit you have that, okay? So in our first scenario, we're going to draw, for both of these, we're going to draw one card out of the deck. So there's really only one trial, there's one occurrence of pulling a card. So the difference between this and the fundamental counting principle, which we've used a lot, is we're not going to pull 2 cards. So we're not trying to find the probability of pulling a jack and then the probability of pulling a queen. This is one card, right? So we're doing this one time, and we're going to have this kind of compound probability where we can get this or this. Okay? So the first thing we have to think is this mutually exclusive, or is this inclusive or overlapping? Is there a way that you can pull one card and have it be a jack and a queen? The answer is no. So this right here is mutually exclusive. Okay? So the formula for finding a probability of one event or another event when we're mutually exclusive is this. The probability of A or B is equal to just the probability of A plus the probability of B. And that's it, okay? So the probability of jack or queen is equal to the probability of jack plus the probability of queen, right? So we just find them separately. So how many different ways are there to pull a jack? Well, there's 4 jacks, because there's a jack of diamonds, a jack of hearts, a jack of clubs, and a jack of spades. And there's 52 cards total. So there's 4 ways to pull a jack out of 52 total cards, okay? But there's also 4 ways to pull a queen, because there's a queen of diamonds, a queen of hearts, a queen of clubs, and a queen of spades out of 52 options. Now we could simplify right here if we wanted to. These are each going to come out to be 1 over 13, and you could add it that way, or you could simplify at the end. Now since we're adding here, we have common denominators, we're not going to add these. We're just going to keep that common denominator. Okay. So what that comes out to be is 2 out of 13. Okay, so that's how you find the probability of pulling a jack or a queen out of a card. But remember, we're only pulling the card once. So we're not really using fundamental counting principle here and multiplying the number of ways for these things to happen, because we're only, the way they use events, or the way that we use the word events, can be kind of tricky. Sometimes we overlap the word events with trials, and so that can be confusing. So it looks like, there's 2 events here, right? There's this event or this event. But there's only one trial. We're only pulling one card. So the fundamental counting principle, we're actually, something's happening, they're separate things that are happening, and this is only one thing that's happening. We just want to see, look, jack or queen is one event. Okay, it's one pull. All right, so let's find the probability of jack or black. Okay, so we got to think about, is this mutually exclusive, or is this inclusive? Is there a way to pull a jack and a black card at the same time? And the answer is yes, there is. So, because there's 2 blackjacks. So we're going to call this inclusive, which means that we have to use a different formula. So the probability of A or B when we're talking about inclusive is we have to add the 2 probabilities and then subtract the overlap. So it's the probability of A plus the probability of B minus the probability of A and B. That's what we're gonna have here. Okay, so let's kind of write these out. Probability of A in this case would be the probability of Jack, right? And then we're going to add the probability that we pull a black card, and we're going to subtract the probability that we pull a black Jack. Okay, that it's black and it's a Jack. Okay, so probability of pulling a Jack. Well, again, there's 4 Jacks in the deck, and there's 52 cards total. So 4 Jacks, 52 cards. Okay. The probability of pulling a black card, there's 26 black cards in the deck. Half the cards are black. So there's 26 over 52. But here's the thing. If we include this, in this 26 cards, this 26 black cards, 2 of them are Jacks, right? And so what we've done is we have 2 black Jacks in this group, and we added that to 2 black Jacks in this group. So we basically use those same 2 black Jacks more than once. We counted them twice. And so we're going to have extras if we do this. Because again, they're included in this group and they're included in this group. We counted them in both groups. We only need to count them in one group. We don't want to count them twice. So what we have to do is we have to subtract the probability that we have a black Jack. Because there's 2 black Jacks in this group and there's 2 black Jacks in this group. But there's only 2 black Jacks in the total deck. We don't have 4 of them. So we have to subtract the probability that we get a black Jack. Now, there's 2 black Jacks in the deck of 52. Okay, so this is the extra piece. We didn't have to have that piece up here because these are mutually exclusive. There was no overlap. There is no way to pull a Jack and a Queen at the same time. But here, there is a way to pull a black card and a Jack card. So we have to subtract the and part. We have to subtract the overlap section. So 4 plus 26 will be 30, and then 30 minus 2 is 28. This is 28 over 52. So common denominators, cool, we're good to go. And then we can simplify at the end. So definitely 2 goes into both of these. So if you divide this by 2, you're going to get 26. You divide this by 2, you're going to get 14. Okay, looks like we can go one more step. So we're going to have 7 here and then 13 here. And there's as far as we can go. Okay. So again, there's different formulas for mutually exclusive versus inclusive. If there's overlap, you have to subtract that overlap. Otherwise, you're counting the same outcomes more than once, and that can be a problem.